Alright, for this example I want to make a closure in R to round the Binet function to get a vector of Fibonacci series values and then select them using a modulus, using another function operator. So this is all about using function operators because I just read Advanced R by Hadley and wanted to get some practice in, and also show off org mode, org-babel, and ESS variously. So I'm going to launch straight into this. So the Binet function is that it always rounds to the nth or xth term of the Fibonacci series. And then we're going to have a function operator over here for rounding, which just adds 0.5 and takes the floor because that's what the Wikipedia page about the Binet function was doing. And modulo zeroing, so I thought we better, if we're making closures, so we're capturing the environment of the function that created the function. So we better have some varying parameters in there. So it'll be k, the modulo equals 0 values that we want to zero out, and opposite day, which on opposite day the opposite values get zeroed out. So we're returning a function of some x such that, so the result is going to be the result of the input function, but values that modulo k are not equal to zero on opposite day get zeroed, else the modulo k's equals zeros get zeroed, and then we're returning, and then the new function returns that result. So Control C, Control N, hit Control L a couple of times. So we're going to load function blocks using NoWeb, org-babel's NoWeb, to pipe those source blocks around. Use function operators on the Binet function to make a function that rounds them to the Fibonacci values. Then 0 modulo, hang on, let's go over there. Control C, Control X, Control L, inline latex fragments. Running, great. So we go get that get Binet source definition, my rounding modulo filter per has reduce in it, which we're being super functional, so throw those functionals in here. So, and we're using quote to show the names of things that we did, or the expressions of what happened rather. So just take the Binet function of 1 to 10, the deviations from the integer values are small, so that will show up as the actual Fibonacci terms. Then we're going to use a reduction to sum those. Then we're going to make our filtered rounded function f, run that, and we're gonna capture a different environment as well where opposite day is true. And Control C, yes, I would like to evaluate that on my system. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Then we reduce 143. 143 minus 21 minus 3 is 119. Similarly, 3 plus 21 is 24. And because we're in a interactive data visualization language, let's use NoWeb to go get our example source block we just looked at, have a data frame with those values in it, and use ggplot modified by tidyr and dplyr to plot that. Control C, yes, I would like to evaluate that. Let's go to results there, and Alt-X, org, display inline images. Great.